Hi everyone. So today we will discuss how to differentiate different functions. From the first principle of differentiation, we have observed the differentiation or differential coefficient of x to the power n, sin x, cos x, tan x. So here we will just see how to simplify problems using all these concepts. So differentiation of, if you consider suppose y is equal to x to the power n. This is an algebraic function, y is equal to x to the power n. And if we want to calculate dy by dx of this, any differentiation of y with respect to x, so that we have observed from the first principle, it is nx to the power n minus 1. So either we can write like this, or this y can be replaced as x to the power n. So we can write dx to the power n upon this dx. It is equal to nx to the power n minus 1. Now, so these are the different ways to represent it. So here also you can see differentiation of x to the power n with respect to x, because y is a function of x, so we are differentiating y with respect to x. So it is differentiation of x to the power n with respect to x, and that becomes nx to the power n minus 1. Here, as far as the conditions are concerned, x belongs to real number, this n also belongs to real number, and x is positive. So under these conditions, we can directly use this relation and we can simplify any problem. Let us say you have y is equal to x square. So if we have y is equal to x square, so here n it is equal to 2. So if we want to calculate this dy by dx of this, any differentiation of this y with respect to x, simply we can write 2x to the power 2 minus 1, n x to the power n minus 1, so it is simply 2x. So that way we can write 2x power n minus 1, that gives you 1 here, so it is 2x. Similarly, x cubed, so that will be equal to how much? 3x squared. X to the power 5, that will be equal to 5x to the power 4, and so on. So these are the ways that we can differentiate this under the condition x is real, n is also real, and x is positive. Now, if you consider suppose y is equal to x to the power x. Let us say y is equal to x to the power x. Now here we can't use this relation because here x is variable and this x is variable. So both are variable here, but here when we consider this x to the power n, so x is variable but n is constant. So then only when n is this constant, then only you can use this relation. If x to the power x, if x is also variable, we can't say that the differentiation of this is x to the power x minus 1. In that case, it won't be applicable. So you have to be careful that here it should be constant, not a variable. So here we can't write this as x to the power x minus 1. We have to meet these conditions, then only we can use this relation directly and we can simplify any problem as far as the differentiation of such functions are concerned. In fact, this becomes your exponential or logarithmic function, and using those concepts of exponential and logarithmic functions in the later classes, we will discuss how to differentiate such type of functions. Now suppose y is equal to 5x squared, then what will be the differentiation? So from the rule of differentiation, we have observed that if we have y is equal to suppose some constant kx, then the differentiation of this, and dy by dx of this is equal to k into differentiation of this. So into differentiation of this means this k into dx upon dx means differentiation of this. So dx upon dx, that becomes 1, so it is equal to this k. So here y is equal to k into x, k is taken out of the differentiation of this differentiation of this variable, because k is constant, x is variable. So we can write this as k dx upon dx, so that is equal to k. So finally here also you can say 5 into x squared, so that becomes 2x. So this will be equal to how much? 10x. 5x squared, so differentiation it is 10x. So dy by dx, it will be equal to 10x. So this is your dy by dx of this. So that way we can calculate differentiation of any algebraic functions. Now here, let us see these trigonometrical functions. Differentiation of sin x, it is cos x. So if we have again y is equal to sin x. So if y is equal to sin x, and if we want to calculate y with respect to x, again we can write dy by dx, it is equal to cos x. Now how this relation is achieved, that we have seen in the previous lectures, that it is from the differentiation from the first principle. So now once we have learned how to differentiate using the concept of the first principle, so always we don't need to go for differentiation using the first principle. We can use those concepts and we can proceed further to simplify the problem. So the standard relation is, if y is equal to sin x, then dy by dx means differentiation of y with respect to x, that becomes your cos x. Now you can use this relation directly whenever it is needed, till it is asked that differentiate this function with respect to or using the concept of differentiation from the first principle, then we will use all those formal steps. Otherwise directly we can make use of this standard relation and we can simplify any problem as far as the differentiation is concerned. Now suppose again we have y is equal to sine 2x. Let us say you have y is equal to sine 2x. Then what will be the differentiation of this? So we will use the different concept to simplify this problem. Suppose 2x it is equal to, let us say, z. 2x is equal to z. So now you will get this relation, y is equal to sine of z. Okay. Now here we have assumed 2x is equal to z, or you can say z is equal to 2x. Either way we can write. So y is equal to sine z. Now here we have replaced this 2x as z. It means now z is a function of x and here y is a function of z. So now we have two different kind of functions. Y is a function of z and z is a function of x. But we need dy by dx, we don't need dy by dz. So just using this standard relation, first let us consider dy by dz. So dy upon this dz. So that will be equal to how much? Cos z. So just using this relation. So dy by dz, it is equal to cos z. But our intention is to calculate dy by dx. Now let us calculate from here. Z is a function of x. So again we can differentiate and we can calculate dz upon this dx, because z is a function of x. So dz upon dx, it is equal to 2. dz upon dx, it is equal to 2. But we are supposed to calculate what? Dy by dx. So dy by dx, can you write dy by dx is equal to dy upon this dz into dz upon this dx. So that dz and dz gets cancelled and we have dy by dx. So dy by dz is equal into dz upon dx, that is equal to dy by dx. This is our requirement. Now dy upon dz is known to us and that is cos z. So this is equal to your cos z into dz upon dx, it is equal to 2. So this becomes twice of cos z. But z is equal to how much? 2x, because our problem is y as a function of x. So we have to answer also in terms of y as a function of x. So dy by dx from here twice of cos z. So this becomes your twice of cos 2x. Z is equal to 2x. So we have replaced twice of cos 2x. Okay. So finally we are getting dy upon this dx is equal to twice of cos 2x. Now you can see here y is equal to sin x. So if it was only sin x, dy by dx, we calculated cos x. So y is equal to sin x, so dy by dx, it should have been cos 2x. But here we are getting a multiplication factor, that is 2. This 2 comes from where? We get this when we have replaced this 2x by z. So we have z is equal to 2x, so dz upon dx is equal to 2. So from here we got this factor, so that it becomes twice of cos 2x. So this way we can simplify. This is termed as your function of function, because here we have introduced one function this, another function this. So if you can consider that function of function, y is a function of z and z is a function of x. So when it is function of function, then we have to consider this kind of substitution. Just consider this substitution, differentiate first function, differentiate the second function, establish a relation between them, how to calculate your required quantity. That is here, our required quantity was dy by dx. So we got it as dy by dz into dz upon dx, and from there finally we got this relation. So these are the steps that we need to consider when you are differentiating function of this function, because here 2x itself is a function and sine itself is a function. So it means it becomes function of function, that is termed as your composite function. Function of function, that is termed as composite function. So you can write f of x. f of x means there is a function f of x, and again we have another function f of that f of x. So this itself is a function f of x. Now another is f of this f of x. Okay, so this becomes composite function. We can have combination of 3 functions, we can have combination of 4 functions. Just we can consider this example. Suppose we have y is equal to sine of log of square root of cos x. Let us say this. So how many functions are there? Sine is a function, logarithmic function, again square root function, again trigonometrical function. So these are the combinations of different functions. So that becomes your composite function, and there we need to consider f of x, f of x. We can have f of x, and so on. So it can be combination of many functions. So that way, so one by one we will differentiate. We will establish the relation according to our required quantity, and from there we can achieve our final relation. So this is step by step. But do we have so much of time to do all these things? Because when you differentiate dy by dx, y is equal to sine 2x, and someone asks you to calculate dy by dx, and they will give you half marks for this, even not that one. So just for that one, how can we consider so many steps, and why should we waste so much of time? So simply y is equal to sine 2x, we will just write dy by dx is equal to sine differentiation, it is cos. So it is cos 2x. Differentiation of 2x, it is 2. So multiplied by 2. So that's why. Now why I have done this, I will explain it. This is also termed as the chain rule. One by one we will differentiate and we will multiply. Why multiply? Why not addition? Why not subtraction? Why not division? That we have seen here. Because one by one we have differentiated every function, and finally we got this relation. And to achieve this our required relation, we have observed that dy by dx equal to dy by dz into dz upon dx, because this multiplication, so that these two terms are eliminated and we are getting this dy by dx. So this becomes a chain rule. One by one differentiate the functions and multiply them, you will get the final differentiation. So I will just again analyze all this. So y is equal to sine 2x. This we need to differentiate. Here we have sine of 2x. So sine, first function is sine of 2x, and second, so this is your trigonometrical function. Another function is algebraic function, and that is 2x. So first we will differentiate trigonometrical function. So first we will differentiate trigonometrical function. So dy by dx, sine of differentiation, that is cos. So sine of 2x, so that becomes cos 2x. Then we will differentiate what? The algebraic function, and that is 2x here. So differentiation of 2x is what? 2, and we will multiply them. So just multiply. So that is your simplification as far as differentiation of sine 2x is concerned. So dy by dx equal to twice of cos 2x. Now why this multiplication? That we have already discussed. Okay, so that way we can consider. Similarly, suppose you have y is equal to sine x cube. Y is equal to sine x cube. Then what will be differentiation? So again we will consider dy by dx. Sine x cube. So again first we will differentiate the sine function, means the trigonometrical function. So that becomes your cos x cube. Okay. Next is the algebraic function, and that is x cube here. And differentiation of x cube is what? 3x square. So multiplied by 3x square. So this becomes your 3x square into cos x cube. So this is the differentiation. First, the sine function differentiation is cos, so it becomes cos x cube. Next is x cube, that is an algebraic function, so we will differentiate it, and that we get 3x square. Multiply that, so it becomes 3x square into cos x cube. So that we can do this way. So again, let us consider y is equal to, suppose, sine 3x. So again, dy by dx, we can consider cos 3x into differentiation of 3x, that is 3, so into this 3. So 3 into cos 3x. Okay, so any type of problem we can consider like this. Now, I hope this is clear. Now suppose so we have this sin x, so differentiation is cos x. Similarly, we have differentiation of cos x, it is minus of sin x, and all other relations that we have discussed for sin x, that is sin 2x, sin 3x, sin x cube, and so on. So that can also be considered. Suppose, just one more example we can take here. Y is equal to, suppose, sin square x. Y is equal to sin square x, means square of sin x, square of this trigonometrical thing. Then how to differentiate it? Again, we will consider sin square x is equal to, suppose, z. Let us say, or z is equal to sin square x. Okay, so when we consider z is equal to sin square x, so this becomes what? Y is equal to z square. Sorry, let us consider z is equal to sin x, not sin square x. We have to differentiate y is equal to sin square x. So suppose z is equal to sin x. So this function becomes what? Y is equal to z square. See this. After this substitution, we have replaced, or we have converted this trigonometrical function into an algebraic function. So z is equal to sin x. So here your problem is now y is equal to z square. It is same as y is equal to x to the power n, z to the power n. So let us differentiate it. So dy upon this dz, this becomes your twice of z. Dy by dz, it is equal to twice of z. And here dz upon dx, that will be equal to how much? Cos x. dz upon dx, that is equal to cos x. So from that, again we need to calculate dy by dx. So dy upon this dx, that is equal to your dy upon this dz into this dz upon dx, and that is equal to how much? Twice of z into dz upon dx, that is cos x. Okay. Now twice of z, that is equal to how much? Twice of z is equal to sin x. So sin x into this cos x. So again we can calculate like this. So twice of sin x into this cos x. Hope it is clear. So this way again we can differentiate. So whenever you feel any complication, try to use this method of substitution. Substitute one parameter with respect to another parameter. Some steps will increase, but you will get the correct answer if there is a very complicated situation or a complicated problem. Otherwise, we can use our common sense. Y is equal to sin square x. Just assume that it is not sin square x, it is x square. Then what you would have done? So x square differentiation is what? Simply twice of x. So we will differentiate sin square x. So twice of what? Sin x. Twice of x square means twice of x. So x square means twice of x, so twice of sin x into differentiation of, so we have, first you have differentiated what? Squared function. Squared function, it is an algebraic function. So we have differentiated this squared function using the concept of x to the power n. So it is twice of sin x into next will be what? We have already differentiated this too, that means the square function, but we have not yet differentiated this trigonometrical function sine x. So now differentiation of what? Sine x. So that becomes cos x. So twice of sine x into cos x. Once you use this, your chain method or your common sense using different functions, sometimes you will need to relate this trigonometrical function in general with the algebraic concept, and we can proceed further. So sine square x, if we assume instantaneously that it is not sine square x, it is x square, then what would have been our differentiation? Twice of x. So twice of x here, because it is not x, it is sine x, so it is twice of x, means twice of sine x into. So we have differentiated square function. Now you need to differentiate trigonometrical function sine x, and it is cos x. We have this multiplication. Why multiplication? That we have already seen. So we have calculated dy by dz, we have calculated dz upon dx. dy by dx is this into this, and so finally we have this relation. So one by one we have to differentiate and we can calculate. Now, so some of the statement that I will be just mentioning here, that is not the language of mathematics, but just for your understanding, just for your clarity, I will be just using this. Start differentiating from the outer function to the inner function. From the outer to the inner function, and just multiply them, you will get the complete differentiation. Now see how we will consider what is the outer function and what is the inner function. These are just you can say these languages are used only to understand and only to simplify problem. It has no significance as far as mathematical rules or regulations are concerned. So here you can just see this. Y is equal to sine square x. Okay, so y is equal to sine square x. So we can write sine x whole square. So this is your outer function, this is inner function. Because when we operate, so we will write sine x into sine x. So this is outer and this is inner. So y is equal to sine square x. So differentiate this from outer to inner function. So differentiate this. So it will be twice of sine x. Here, because we are assuming it is nothing but x square. So twice of x, so it is twice of sine x. So we have differentiated this outer function. Now differentiate the inner function. So it becomes your cos x. So we have this relation. Similarly, we can consider some more example here. Suppose y is equal to square root of sine x. Okay, so when we consider square root of sine x, so we can again represent it as sine x to the power 1 by 2. So now again we can use this concept. So x to the power half means sine x to the power half. So if you differentiate x to the power half, how much you will get? Half x to the power half minus 1. So that way we will write. So dy upon this dx, it is equal to half x to the power half minus 1 means sine x to the power half minus 1. Okay, into differentiation of what? This sine x. So this becomes your cos x. Now let us simplify this. So it is half. This will be sine x to the power half minus 1 means minus of half. When x to the power minus half, how will you write it? You will write this is 1 upon x to the power half, or simply we can write 1 upon square root of x. So that way we can represent it. So it is 1 by 2. We can write square root of sine x into cos x. So this becomes your cos x upon 2 square root of sine x. So we can simplify and we got this relation. So here the outer was 1 by 2. So we have first differentiated this using the concept of x to the power n. So sine x to the power half minus 1 into this 1 by 2. So that can be represented like this into again the differentiation of inner function. So it is cos x. Then we can simplify, we can arrange the term and you can have your answer. So this way we can proceed further. So if there are suppose many functions where you feel directly you won't be able to do like this, then replace the function, use the method of substitution that we were doing, and then consider dy by dx equal to what? This into this into this. See the terms what are to be multiplied there, and accordingly you can calculate that. Now, so we have discussed, I think, all the situation that you can come across. So differentiation of sin x, it is cos x, and that way we can calculate sin 2x, sin 3x, sin square x, sin cube x, and so on. Similarly, differentiation of cos x, it is minus sin x. Whatever things we have discussed here, all are applicable for this. We can have cos 3x, we can have cos 4x, we can have cos cube x, we can have cos to the power 4x, square root of cos x. So similarly, we can do that. Same relation holds true for tan x also. So differentiation of tan x, it is sec square x, and again all other rules that we have discussed, that is applicable here as well as here. Sec x, that is sec x into tan x, cot x minus of cosec square x, cosec x, that is minus of cosec x into cot x. So these are your standard relation. Now how to modify things, how to calculate functions of differentiation of function, that we have just seen. There is nothing to remember. Only thing you have to analyze and simplify. Sometimes you need to use the method of substitution, or directly you can apply your mind and you can simplify it. Now we can see this exponential as well as the logarithmic functions. So if we have, suppose, y is equal to log of base ex. This is the standard form of the logarithm. Y is equal to log of base ex. Okay, here if the base is e, directly we can have dy by dx is equal to 1 upon x. That we can see. Again, we calculate all these standard relation using the concept of first principle of differentiation. So y is equal to log base e here. Then only you write 1 upon this x. Okay, but if there is change in the base, suppose you have to calculate differentiation of log of base a, then how to simplify that? So if we have, suppose, y is equal to log of base ax, then how to simplify this? So we can have the change of the base, because the standard relation we can use this. This is the standard relation. We can use that standard relation only if the base is e. Here base is different. So first we can change the base. Log of base AB x, it is log of base AB, it is equal to log of base A. If you want to change this base A to suppose some base C, then that gives you log of base AB, it is equal to log of base CB divided by log of base CA. This is the relation. We want to change this base A from A to C. So this will be equal to log of base C. If you want to keep the base C, this B remains same as it is, divided by log of base C, this A. So this is the change of base as far as the logarithmic relations are concerned. Now using that concept, using this concept, now we can consider. So y is equal to, suppose, log of base ax, log of base ax. Now we want to differentiate. Before differentiation, we want that its base should become what? This e, the exponential function, this e, so that we can make use of this standard relation. So let us change the base. So this can be represented as y is equal to log of base e x divided by log of base e a. We want to change this base a from a to e. So log of base e x, that will remain same. That just now we have seen that how to convert the base from a to b or b to c, like that. So log of base ex divided by log of base ea. Once we have this relation, so now you can see this can be represented 1 upon log of base ea into log of base ex. So y is equal to now 1 upon log of base ea into log of base ex. Now this is what? This is a constant. because there is no variable here, no x, that y is there. So this is constant. Differentiation of y is equal to kx. That becomes what? Dy by dx is that constant k into differentiation of that x. So here also this will remain as it is. We will need to differentiate only this, and differentiation of this is how much? 1 upon x from this relation. So just using this relation we can differentiate. So dy by dx is equal to this into differentiation of this. So from here you can write dy by dx is equal to 1 upon log of base EA into differentiation of log base EX, that is 1 upon x. And here that relation you can see here. Differentiation of log of base EX equal to 1 upon x into 1 upon log base EA. You don't need to remember this relation because the logarithmic conversion as far as the base change is concerned, that is known to you. And if it is not known to you, make sure that it is always there in your mind. It should always circulate in your mind. So once you have that relation, change the base, make it to the standard form of this, make use of that, and you will calculate it. Okay, so always try to keep minimum of the relations. Okay, always try to apply your mind, always try to use your common sense. That gives you more efficiency and that gives you a thinking process, your own thinking process. Okay, so that you can simplify any type of questions when you are ready to apply your mind. So that way we can have this relation. Now let us consider this exponential function. Again, if y is equal to e to the power x, again differentiation it will be dy by dx is equal to e to the power x. See, there is no change in this. Again, if we consider, because here e to the power x, so this is your exponential function. E is constant, x is variable. So when the power is in the variable, so that becomes either an exponential function or it becomes a logarithmic function. So similarly, if you consider, suppose y is equal to a to the power x. E is a standard quantity, a can be any constant. So any constant raised to power this variable. So y is equal to a to the power x. Then how to differentiate it? So it may, again, here you can see this is standard relation, but I will again suggest you not to use this. Keep the concept in your mind. Y is equal to a to the power x. Take log both the sides. So when we take this log both the sides, so log of y, it will be equal to your how much? X log a. X log a. I hope you know this relation. Y is equal to a to the power, so log m to the power n. That is equal to what? N log m. So n log m. That's what I have written here. So taking log both the sides, log of y is equal to x log a. Now we want to calculate what? Dy by dx. So differentiate this function, log of y. So log of y, and if you don't write any base here, I will not mention any base here. So it is assumed that the base is e. So when you are taking this base e, either you particularly mention that base e or you can ignore it. It is already understood. If nothing is there, it means it should be considered as base e. So taking note of that, we can differentiate log of y. So again we will differentiate what? Log of y, because we need to differentiation of log of y first, because we need to calculate dy by dx. So can you write log of x differentiation is 1 upon x. So log of y differentiation will be 1 upon y. So here you have differentiated logarithmic function first. Again I am coming back to that chain rule. I have differentiated the logarithmic function and that becomes 1 upon y. And differentiation of y with respect to x is what? Dy by dx. So that becomes your dy by dx. Why I have multiplied this? Now that is known to you. Okay, so 1 upon this y, log, so 1 upon y, into differentiation of y, that is dy by dx. You can say, sir, log of x, it simply becomes 1 upon x. Log of x, it becomes 1 upon x into what? Differentiation of x. Here also we are doing the same thing, but it is not visible. It is not visible just because dx upon dx, and dx upon dx is what? 1, and that's why we don't write it. But here it is not x, here it is y, and y is to be differentiated with respect to x, and that's why dy by dx. So it is not 1, that's why we need to write dy by dx is equal to. Again this log of a, it is constant. Constant into differentiation of x, that will be what? k into differentiation of x, that is 1. So log of a into differentiation of x, that is 1. So simply it becomes log of a. Okay, so from this we can write dy by this dx, it is equal to log of a into y. This y here, 1 upon y, so this will go this side, so cross multiplication, so you have log of a into y. So differentiating that, we got this dy by dx equal to log of a into this y. Now when we calculate this log of a into y, so y is equal to how much? Y is a to the power x. So we can write dy by this dx is equal to log of a to the power x. Hence dy upon this dx is equal to your log of a into a to the power x. So this becomes your relation dy by dx log of a into a to the power x. This is in the bracket. So that we can consider. So this is a to the power x into log of a. Now here, as I have told you earlier, when we don't write any base, so it is already understood that the base is e. So log of base e, a into e to the power x. So that way we can differentiate it. So simply this is your standard relation. Once you know this, so there is no need for any other relation. So that way we can differentiate. So we have discussed all the relations for algebraic function, trigonometric function, exponential and logarithmic function. Now we will make use of all these standard relations to simplify problems based on differential coefficient or simply the derivatives. Thank you.